So you see Singapore is here, right? So we have the link to Japan and Korea. We have the link to US and to Australia. All right. So that's where the data we're transferring. Okay. So the US side is actually goes all the way to Chicago. As you know, Chicago was freezing about a week or 2 weeks ago at minus 40 degrees. Okay. The rest down under here was sweltering at plus 46 degrees. Right? Huh? Okay. So the other thing I want to show you is that the IoT test bed that we set up, all right, each sensor node is this one that we built. Okay, it's about the size of this guy here. All right, built on a Raspberry Pi 3. Okay, running Linux. Okay, and then we put in WRT so that it behaves as a Wi-Fi sniffer. And then on top of it is a daughter board. The daughter board. All right. So let me see if I can find the. So this is what it looks like. So you can see that the Raspberry Pi is here. This is the sensor board, the growth board. So this guy just does the environmental sensing of temperature, humidity, light level, audio level, and something like 10 to 12 different types of chemicals. Okay, so this is the part where I've taken up the white colored perspex, and the bottom of it is like that. Okay, so this is attached to the ceiling. So when we do that, we can put it into this test bed here. This is where my research lab is. Okay, in IQ building. Okay, so you can see the SN1, SN2, SN3. This is where we put it on the ceiling. So altogether there are 23 of them, up to SN23 over here. Okay, SN23 here. So this is collecting all this data. All right, been collecting for 2 years now. All right, okay. So all this data is archived. It's archived into this place. Archived into this place. Data commons. All right. So if I go in, so you can also go in and look. So it's all the way down here, IoT sensor, and then you can pick up the data on a week at a time, all right, and what it contains are all this data, all right, and the timestamp, so that for the AP sniffer, it sniffs the AP serial, it sniffs the Wi-Fi, all right, sniff meaning that it detects all APs in the environment, it detects all Wi-Fi devices, whether they are handphones or laptops, in either probing or associated mode. It has the MAC address, but this is encrypted to comply with PDPA, Personal Data Protection Act. Okay, it's encrypted, all right, and so on. And then the AP MAC address is there if it is associated with, that means you log in, okay? And then these are the things for the environmental sensing. Okay, timestamp, temperature, humidity, gas, carbon monoxide, nitrogen oxide, methane or whatever. All right. Okay, methanol, hydrogen, etc. And then light level, sound level, etc. So all this is archived. So let's say if I was to pick a week to download, today is this week, right? last week's to download. I can submit to download. Then download it here, as you can see. All right, so you have access to this as well. Okay. So it's quite large because of the sniffers. Let it download and then we'll see what happens. So this was built by my research staff together with one final year project student. Still downloading. No. So it will look for changes, all right? So for the environmental sensing, I think we're doing it every minute. Every minute we are collecting a set of environmental data. But for the Wi-Fi one, it's dynamic. As and when there's a change that occurs, then it updates. Okay, you see the data after you do one minute. Okay, all down already. Okay, let me get the data. Okay. There it is. So these are all the data. So if I go in here, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Right, Sunday was 10th of February, right? Okay. So if I go in, let's say I take this Wednesday, it's extracting the file now. If there's too much activity, it will complain because the Excel can only open 1 billion rows. Anything beyond that, it cannot open. Alright? So let's see what happens. Yeah, complain, right? There's more than 1 million rows here. So you can see we have the different sensors. Just now you saw sensor 1 to sensor 23. Okay? So this is the sensor MAC address. Alright? This is the sensor time. Then these are the devices that were infected. That's the MAC address, as you can see, which is hash. Okay? This is the RSSI value. Alright, this is the channel that it's using, and you can see whether it's associated or probing mode. Alright, and then this is the AP address. If it's associated, there will be a AP address. If it's in probing mode, there is no AP address because it's not logging. Okay, so a couple of them are using all this data for their project. 5003 project. Okay, but sometimes I also ask the students, go and find out what is your MAC address, go to the internet and encrypt it, see whether you can find yourself. SHA1. Okay, alright, then you can track who that's dangerous. So basically, we are using this, making it available for people who want to do research. They need data, you can pick up data. All right. So that's what this data commons is all about. So this is this IoT. The other one is we archive the LTA traffic data, the weather data. We also had this thing which has been decommissioned now. This was the last time now, US shuttle bus service with the Wi-Fi. Okay. This one is the device detection, Wi-Fi device detection across the campus. So let's say we are in engineering, SDE, and you want to go E1, say, and select floor 6, okay? Click, live, this is right now. These are all the devices that are detected. All right? So for example, if I, you can see the SSID, this is the student, blah, 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 and then he's associated, and so on and so forth. All right? So we have all this data which can be used for research. This for research. So again, a couple of my students are trying to do analytics for crowd dynamics, where people gather, how long they stay in a place, where did they move from A to B, etc., etc. Okay, so that is the demo that I wanted to show you. So in any case, you come back to the comments. Okay, of course you can also download historical data. All right? Yeah, we used to have a project on canteen crowd, but again this is discontinued. So you can go in with your NUS ID to access that data. Right. So with that, we finished our show and tell. So now we come to tutorial 4. Shouldn't be too long, but straightforward. Okay, tutorial 4, question 1. Nodes A, B, and C operate in a CSMA CA wireless network in which nodes B and C intend to send data packets to node A. The durations of the propagation delay is alpha, DIFS is 3 alpha, SIFS is 2 alpha, ACK is 5 alpha, and the data packet is 10 alpha. Assume that the medium is busy at node A initially. During this period, the packet arrives at node B, which selects a backoff counter of 5, while a packet arrives at node C, which selects a backoff counter of 3. Draw a timing diagram to illustrate the data transmissions among the 3 nodes, and how long does it take to complete the transmissions and acknowledgements of the 2 data packets from nodes B and C to A. Okay. So we have node A, B, and C. Alright, right now it's busy. And somewhere in here, a data packet arrives. So this guy has a backoff of 5. And this has a backoff of, 3. 3, right? Node B has a backup of 5 and node C has a backup of 3. So B has a backup of 5 and this has 3. Okay, so idle channel. So you will wait DIFS here. So this is DIFS. After DIFS, you will count down. Back off. 1, 2. So this also count down. 1, 2, 3. See, this guy still got 2 more, right? But this one finished already. So that means he will grab the channel first. So you grab the channel. So this will be the data. Okay? right now I have not put in the propagation delay yet. I'm assuming propagation delay is 0. Okay? Then you will have to wait. SIFS. Then he sends the acknowledgement. Okay? So this guy all finished already. So now, after the acknowledgement, channel is clear. So this guy has 2 more backoffs to go. Right? No, not yet. You have to wait the IFS. Don't forget. Right? Okay? Then you got 2 more backups to do. Because 3 are already done there. Got 2 more to go. Okay. Now you can send his data. Alright, after send the data, SIFS. Send the acknowledgement. And then you're finished. Okay, got it? So now we have to find the time from here to here. Okay? Alright, so that's all in the answer. I think you already have the answer already, right? No. Not yet. Now you have. Okay, so you can see the whole pattern. It's just that I put B instead of C. Alright. Okay. So, what's the total time? The time to send the first packet, which is this cycle here. This cycle here. So it's DIFS, 3 backoff packet, then the propagation delay. Okay, so DIFS is this guy, 3 backoff is this guy, packet is this guy, alright, plus propagation delay. Then SIFS, then acknowledgement, then packet delay. Because every time you send a packet, there's a packet delay, right? Because of propagation. Okay? And then the next one is this guy from here, DIFS, then 2 more backoff, packet delay. This guy. Then SIFS here, acknowledgement here, packet delay. So add everything up, 49 alpha, or 49A. Okay? Got it? Any questions? So let's do question 1. Question 2. Figure Q2 shows a network topology where the link metric is the probability of successful packet delivery. Node 1, so this is node 1 over here, has packets to send to node 7. 7 is over here. So 1 is here, 7 is here. Determine the best route to take and explain your answer. Now, these are not cost, these are probability of successful transmission. Okay? So if you're going from hot to hot, the total probability of success is a product of all these probabilities. Correct? Okay? So you're going to figure out in this small network of 8 nodes, what are all the different possible ways to get to 7? And calculate the cumulative probability. That's what you need to do. And the one that gives you the highest cumulative probability is the route that you will select. Okay, so example. Let's say I go 157. If I go route 157, the cumulative probability is 0.9 times 0.7. Got it? 0.9. So I can do all this and do all the combinations. So if I do that, these are all the possibilities. 157, 167, 13467. You can refer to your figure because I cannot do pages at the same time. Okay? 12467, 1267, 1268. So which one is the highest? 167 is the highest probability. Straightforward, right? Any questions? We're almost there. Well, three more descriptive questions and we're done. Okay. Describe some of the weaknesses associated with the use of directional antennas in wireless mesh networks. So we did that last week, right? Directional antennas. We gave you 3 examples. Deafness was one of them, right? Being blind is all in the nose, right? Those 3. So those 3. So we do. So it's a repeat of it. So I won't belabor it. Okay. So the first one is deafness, as you saw here. Right. So this is deafness. So in this example, we saw that A is deaf to the RTS because A is pointing in this direction. So this guy wanted to transmit, he didn't hear this RTS. Right? So that's deafness. Right? Okay? Then the next one is circular deadlock. Everybody looking in the wrong direction. Everybody looking in the wrong direction. And the last one, hidden problem not solved. Okay, because of the directionality of the beams. Okay, right? So those are the 3. I won't go into detailed explanation because we already went through that last week. Okay, and then we went through a number of scenarios, right? Remember, we went through a number of scenarios where you have different D mode and O mode for the RTS, CTS, and all that sort of stuff. Okay, and there was a summary table. These are all from that particular page. And the implications of using directional mode, D mode, or omnidirectional mode, O mode, or mixtures of this. Right? We talked about that last week. Any questions? All right, number 4 is this what we covered today. What are the characteristics of the wireless networks that require changes in the existing TCP? We covered 3 things, right? Link quality, mobility, and asymmetrical systems. Right? Those are the 3. Okay, so you can talk about that. So as a result of that, because of the weakness of the wireless link, the weakest link is the wireless link. Then we have to do certain special things. So we saw 2 examples of that. Right? 2 examples. Indirect TCP and SNOOP. Indirect TCP is a method where it breaks the connection into parts. Okay? SNOOP is where it caches it at the base station. Base station negotiates with the mobile host. Make sure this one is done already, then only send the acknowledgement back to the fixed host. Okay, in direct TCP, once the base station receives the data, it will immediately acknowledge already. Okay, so the fixed host thinks everything went well. Okay, so it's blind to all that. So those are the characteristics. And the last part, question 5. What are the disadvantages of using wireline TCP over wireless? Okay, so the disadvantage is this, because TCP for wired network, packet losses are generally due to congestion, not due to link quality for wired. Okay, so it has a much more aggressive way to deal with congestion when it sees packet loss. When does it know that the sender? When does a sender know that there is a packet loss? When he sees double acknowledgements, right? He sees double acknowledgement. And so what does he do? He reduces his congestion window until down to 1. Okay? At the same time, he also extends his backoff or RTO, which you asked me just now. All right? Extends that. So that was very bad. That is very bad for the wireless. Because if anything problem, almost every packet gets corrupted. Then your congestion window will never grow beyond 1. So your TCP throughput, end-to-end throughput will be very, very poor. Okay? Yeah. So that's why you can't use the standard TCP protocol over wireless. Then the second part is describe how indirect TCP deals with the error prone by breaking the thing into 2 connections. The wired part and the wireless part. Okay? Wired part, send acknowledgement immediately, and then deal with the wireless part separately. Okay? Deal with separate part. Alright? But usually for the wireless part, because the base station and the mobile host are usually close to each other, close meaning within a few kilometers in worst case. Right? So the RTT is very low. Round trip time is very low because the distance is short. So as a result of that, you can use a much more robust and reliable transmission method between the base station and the mobile host, as opposed to the full suite of TCP/IP. Okay. To ensure more rapid delivery of the data from the base station to the mobile host. Okay, so all that again, we talked about that just a half an hour ago. All right, and that's about it. That is fundamentals of introduction to wireless networks. Okay, so go and try some of the past quiz. I already uploaded some of that. Try it out so you get an idea of what to expect for the midterm quiz. Okay. There are similar questions like this in the past years as well, so you can also try. Okay. Any questions? So you missed a lot. That'll be on the video. Go into YouTube. I gave you the YouTube links, right? Huh? Yeah.
Yes.
I sent an email to everyone unless you are not in the list. Are there anyone who is doing this on audit? Then you will not be in the list. Yeah. You got the email, right? Yeah. If you still didn't get it, come and see me after. So do have a look at the video. Anything else? That's it. Right. So next time I see you will be on week 8 for tell you about sensor networks. Okay. 2 weeks from now. Next week is week 6. Then we have recess week. Then we have week 7. So he's coming in week 7. The week of 4th of March. 4, 5, 6, 7. So you have a lesson on the 7th of March. Okay? Right. So the IoT template that I talked about just now, we built it together. Or at least we co-funded it together. Alright? Yeah. And feel free to extract the data from data commons. Alright? So it's called data commons. datacommons.us.edu. Okay. If you look at you saw the Cisco MSC data, which is the one over the whole campus. You also can see the location that Cisco has detected of that device. So with that information, we can actually do the identification of where the drops are. Drop meaning a proxy will be your device. Okay. Is there any? Not planned. I have not planned any additional clinics unless you guys want it. Okay, but this week obviously I'm not here. If we do want to have one, we could do it on the same Thursday of recess week. Same Thursday night. It has to be a night because some of you are working. Right? I can do it if you want. Anyone wants a clinic? Yes? 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 Okay, then we meet on Thursday night on recess week. Whoever wants to come, you don't have to come, it's just a clinic. Free and easy. Okay? So in clinic, you just do Q&A. You ask Q, I have A. You don't have Q, we go home. Yeah. Yeah, 28. Last day of February. Okay? Never mind, good tonight early. You can go and have your Valentine's dinner with your girlfriend as well.